We'll be covering how to start a WISP over the next 10 weeks. We'll be going through step by step from evaluating a neighborhood all the way through to actually installing a customer. Hello, I'm Dustin.
And I'm Eric.
Welcome to our very first podcast show where Eric will speak to you in 10 different languages.
Good afternoon. Buenas tardes. Ciao ba. Guten Tag. Y gun la. Hola.
So today we'll be talking about evaluating a potential area for coverage. We'll discuss usable locations and evaluating neighborhoods. We also have a special guest with us today, Jeff Jones.
Hello, everyone.
Welcome to the show. Thanks for joining us.
Good to be here.
So, will you tell us a little bit about yourself?
Well, I've been with Mimosa Networks for about 3.5 years. I'm a network design engineer, and when I'm not designing networks, I'm actually helping out with the product support engineer role.
Excellent. So it sounds like that sometimes you're super busy.
Sometimes I'm very busy.
But hopefully you're doing something that you love, too.
I do. I love it. Love wireless, for sure.
So now we're going to talk to Eric here. Eric, tell us a little bit about your weekend. What'd you do?
My weekend? Oh, we went grocery shopping, my wife and I. And we went to pick up some food for the Chihuahua. I got a little dog about this big. And we had to park. We couldn't go to one grocery store. We had to park in the middle and we had to go to Target. Grocery store, Target. Anyway, Target's got the special Rachel Ray dog food, so we went there to get the Rachel Ray.
I know all about that Rachel Ray dog food.
Looks tempting too, but it's yeah.
Well, I promised that my weekend was just as boring. I went to the store, did housework, sit on the computer all day. I do the Mimosa social stuff on the weekend.
Right.
So, I don't have a whole lot of fun stuff to talk about. So maybe next weekend I'll have something better to talk about. So now we're moving on to the interrogation room where people send us questions and we answer them here live on the air about the show that we're doing today or the show we did last week. So our first question this week is, will you give us some background information on yourselves? Well, I have been in the wireless business for 8 years now. I ran a WISP for 6.5 of those years for a company in Arkansas. And so I pretty much learned everything wireless on the job there. And, well, honestly, I learn new things every day, and it wouldn't be a job if you didn't learn something new every day. I help people now, go out and deploy stuff for those guys, help them deploy stuff, help people troubleshoot. But, that's pretty much all I do. Wireless is my life now, besides my wife.
I know that because I go out there and help you. I've been into wireless and radio since I was probably 8 or 9, and getting into the IT game a little late, and microwave, kind of the microwave part of the spectrum a little late. Also, had 30 years in ham radio. I'm active, and so I'm kind of applying things to upper parts of the spectrum now. We're going up higher in frequency.
Jeff, aren't you a ham too?
I am. Been a ham radio. Not as radioactive as Eric is, but I am definitely been doing it since the early 90s.
So if I get my Geiger counter out, you both are going to spike, right?
We're probably going to spike, yeah.
All right. So moving on to the next question, how much does it cost to start a WISP? Well, it really depends on what kind of equipment you want to deploy, how many employees you have or need to have, how far away the customers are, your truck rolls. You've got a lot of stuff that you have to consider, and a lot of stuff that you have to plan out before you can actually determine how much it's going to cost you to start a WISP. But I can tell you now it's going to cost you a lot of money. So we'll move on to the next question. How do I finance a WISP? Well, there's a bunch of different options out there that you can try. You can see if your town will help you finance it. If they're desperate for internet service, they're going to be more than willing to help you buy equipment. People that your neighbors, if they really want internet service, they might help you with some equipment. Of course, there's always the venture capitalist way where you borrow money from those guys and they invest in your company. You pay them back once you're successful. You can talk to your bank or, any other kind of lender. They might provide you with some money, but you still have to have a business plan formulated and written down on paper before anybody's going to give you any kind of money whatsoever. If you don't have a plan, I wouldn't suspect you'd see any kind of money. So we'll move on to the next question. Do I have to know anything about computers or computer networking to start a WISP? Jeff, do you want to answer that?
Well, you should have a basic knowledge of how computers operate at the network level. I think it's really good just to get a good understanding. There's a lot of courses out there that you can take online that can help you with this. We see a fair amount of customers come in that have basic understanding of computers and how they work, and that's always helpful.
Well, I know Mimosa has a great help site too with tons
Absolutely.
of documentation on our equipment, but some more on that is there are people out there who start businesses that don't know anything about what they're doing. They usually hire good people that do, and if they don't, a lot of those companies end up failing. So you want to make sure that either you know the information or you have somebody that's working with you that knows how to do it. So let's move on here to question 5. What kind of legal obligations are there to running a WISP? Well, this is a better question answered on forums like Wisp Talk, located on Facebook. A lot of those guys are WISP runners for many, many years. They've owned and they've sold and owned more WISPs, so they know the ins and outs of the legal world. But, you can hire a lawyer or have somebody that knows legal that works for you. But the FCC is one of the major things you need to know about. If you start breaking rules with Spectrum or start transmitting over EIP levels, you're going to have some government guys come down if people report you. So it's probably best to ask your questions about legal on the forums where people really are in the know about this kind of stuff. So our last question for today is what is the minimum number of subscribers I should have initially? Well, that's a good question. It really depends on your network setup and how many people you have working for you. But if you're thinking of more of just a ROI, return on investment, most people say it's around 10 clients per AP will help you pay for the equipment you've put on the tower and will help you pay for the bandwidth. But it depends on how much you charge for bandwidth, how much you're paying for bandwidth, how much your equipment is, your lease payments, your power bill, how much you're paying your guys or your girls that are working for you. So you have to do your own studies on how much money you're spending and how much you're pulling in to really know what your minimum number of subscribers are going to be.
You got the insurance cost. If you got to roll a truck out, that's gonna be a charge. You might be the only guy, or maybe you're starting it up and you're solo.
Right. There's a bunch of guys out there who are running Wisp solo, doing installs, service calls, tech support, tower climbing, and it takes a lot to do that. You save a lot of money, but you're working yourself to death too. So, it really depends on how you want to run your business. So moving on here, today's main course is evaluating potential area for coverage. So we're going to go over tower locations, rooftops, relay sites, and topography. And then moving into the neighborhood part of it, we're going to talk about density, tree coverage, competition, and spectrum. So moving on here, we're going to talk about towers. You can build your own towers. Usually ends up being the better option for you. Partnering with landowners or business owners that own the land. You can provide them free or reduced rate service for reduced rate on the land or free land, or there's some people out there who own towers that would be more than willing to let you on their tower to get free internet service. Personal experience of mine is we had a farmer that owned a 300-foot tower that he got from a bankruptcy. Had nothing on it, had no reason to use it, but really desperately needed internet service. We said, hey, we'll come out, we'll give you free service if you let us use the tower. And so after that, we put some Mimosa backhauls up straight to his place, hooked him up with the 10 meg circuit he wanted, used that tower as a relay point for the next town down the road. So you might get lucky enough that you get a free tower out of the deal just from a cheap internet circuit that's not going to cost you more than a few bucks. You can also contract with tower owners. There's a bunch of those guys out there. There's private tower owners. There's American Tower. There's SBA Towers, which is owned by AT&T. Verizon has towers. There's tons of people out there who own towers that are already built. A lot of those have space, but it depends on how much money you're willing to spend. It's always coming back to money here. Depends on the space on the tower, if there's any space, the location. It just really depends on, does it fit your need? And so then we move into rooftops. There's tons of people out there who use rooftops in urban and suburban areas. It's a great resource and a great replacement for a tower. It's a lot easier to actually deploy equipment on a rooftop because it's a flat surface. and it's a lot safer to go on a roof than it is to climb a tower.
Lot easier access. Yeah, and that's one thing. Yeah, you want to have, if you can get it, 24-hour access. Often when we go out to the field, we have to put in a text a day or two in advance, or call somebody, call the landowner, the owner, and get access to this spot. Also, it's a lot easier to work on the platform like that, a lot safer as well. It could be quite populated, and then you're going to pay per kind of square foot or the number of radios or pieces of equipment that you want to deploy on somebody else's site. So all those are those different things. It's also on rooftops and towers. You could find often good grounding and bonding points. You're going to need to protect your investment.
I know one thing that we've seen in the past when I worked for a WISP is that we would set up arrangements and agreements with rooftops where we would provide free internet to the owner of the building in lieu of putting our equipment on top. And that works out to be pretty a sweet deal for everyone, obviously, because there's no money out of your pocket, and it provides a good relationship for that location. So you're able to work with the landlord or the owner of the property. So consider that when you're looking at rooftop locations.
Yeah, as long as you're treating them well and you give them great service and great support, that goes a long way in any world, especially the wireless world.
Mm-hmm.
And so moving on here, we're going to talk about remote relay sites. So relay sites would be where you can't see from point A to point B. You need something in the middle to kind of bridge the gap. There might not be a vertical asset there, so you build your own. Solar sites, or just a site where you can get 110 volt power, or anything where you can relay between point A and B to get service to a person or a group of people. We actually have a solar relay site that we built. Eric and I spent over a month last year building a site out in rural California, Highway 1, where we put some solar panels up, and we actually made what's called the diversity link, which you can see on YouTube. It's actually our first couple of videos there. And
it was a free, we were providing free internet for a company out on the coast, and we were looking at topology using the tools and Google Earth, etc., and found a couple of good spots up on a hill about 400 feet above the beach, above the water, and we're able to relay from point A to B to point C, and it turned out real well. Completely off the grid, solar panels, multiple dishes, and so forth, and remote access, even a security camera on the primary mast itself, and so on, which we found important as far as security and also checking on the weather and such up in the area.
A quick tangent alert here is we built this site because we were having some ducting problems over the bay. This is almost fully over the bay of Monterey there, so ducting occurs when the hot and cold air come in reverse. So it's basically an inversion layer, so it kind of reflects our signal around the bay area, and so we have 2 dishes up using A5C to kind of combat that.
How long is that link, by the way?
Yeah, it's 56 miles. Yeah, we'll see some enhancements with the tropo ducting, and also see some attenuations of some signals arriving out of phase. So, as Dustin mentioned, we'll have two. We have dual dishes, a 30 dB and a 34 dB at different heights, and both feeds out of each dish arrive for a total of 4 feeds into the Mimosa A5C radio, and we're able to combat that 56-mile link. 3/4 of it mostly over the salt water, and with some special firmware to accommodate the signals in and out.
While we're on the TA, Jeff, do you have any experience with Lynx over water? Do you have a lot of guys come and chat with Lynx over water?
We do. We get a lot of customers from, I would say a fair amount of customers from Southeast Asia, where they're trying to make Lynx over multiple island hops. We've had a fair amount of customers in I would say the Vietnam, Cambodia area, where they're trying to provide internet link into a remote location.
You actually are involved with the Farallon Islands, right?
I was. Yeah, about 3 years ago, we actually implemented I'd say about 28-mile link from Sutro Tower location in San Francisco all the way out to the Farallon Islands. And it was really fun. It was quite the boat ride. It's about a 2-hour ride out to the islands there. And one of the most memorable part of the trip was getting off the boat and taking a Zodiac inshore. We were only about 6 to 12 inches off the water in the Zodiac, and if anyone knows the Farallon Islands, this is the breeding grounds for great white sharks. So I'll tell you, it was quite the ride getting into the shore there. I couldn't get off that boat quick enough.
I think we're almost due to go out there and maybe replace some equipment.
Yeah.
So, can you set us up with that?
Absolutely.
Awesome. Sounds like fun. Just as long as we don't fall in the water and get eaten by some sharks.
There you go.
So, all right. So moving on here, back on track. You also want to keep in mind the topography of the area you want to deploy in. Make sure that you're not looking at a tower or anything that's down in a valley when you're trying to get to homes or businesses on the other side of a hill, or a tower that's not surrounded by trees where you don't have any line of sight to where you're trying to get to.
We could see. We go to the maps, go to Google Earth, go to the map tool, et cetera, the design tools, and you could see so much. You get so much information, but it really pays. You got to go on site, get a compass out or whatever you need to do, depending on the link length that you're after, and really look at the topology. There's so many ridges often in some of these places. It's not like kind of flatland. A lot of places are full of hills and trees and things that might not show up on your design tool, so you really got to go out there.
Yeah, those guys in the Midwest are lucky. They don't have really any trees, and they're flat, but there's a lot of people out in the world that have to deal with hills and trees and mountains and everything else that might be in the way. So moving on here, we're going to talk about evaluating neighborhoods, and the first thing you want to look at is neighborhood density. What are you trying to do? Do you want to hit a big group of homes in a suburban area? Are you trying to rake in money? Are you trying to provide internet service to a rural community that's really spread out? So you need to plan out. Are you going to do a mini pop in a small neighborhood? Or are you going to do a gigapop on a tower? So it's just really planning your network. Planning is basically number one step for doing your network. And then you need to consider trees. Trees are a huge attenuator, especially for 5 gigahertz, which is most of our equipment, although we go higher in the spectrum. But the higher you go, the worse the attenuation is going to be. So you need to check and see, if you've got a lot of trees or no trees at all, and plan your network around that as well. Again, mini pops and gigapops can come into effect here, depending on what kind of tree coverage you're looking at. Say you've got one home visible from a tower, you can always backhaul there and then hit all the other homes around that one home if you're in a dense neighborhood. Whereas if you're not, you're out in a rural area, it's going to be a lot harder for you to do mini pops or even gigapops if you've got a bunch of trees in the way. So
you're up at 900 meg, and then you move it into 2.4, et cetera. And you can push the signal through a certain amount of foliage and such. And as soon as you start going higher up in the spectrum, then we see these issues come up more. There's a certain amount of obstructions, Fresnel obstructions, and so on. And then we want to keep error rates and push the data through. And there's more of a challenge as you go up in the spectrum.
Since you mentioned Fresnel, do you want to explain what that is real quick, or either one of you?
You want to hit... Oh, well, so Fresnel in the microwave part of the spectrum. So Fresnel between point A, link A and B, or between a link, between both sides of a link. Let's take 10 gig, or let's take 5 gig at like 10 miles. You need line of sight there, and pretty much the RF envelope or the signal from this side and one side, the other side of the link. It's kind of like a torpedo shape or like a cigar shaped signal or envelope, the pattern. So we don't want that obstructed by trees, foliage, a ridge, maybe some kind of part of a saddle, little mountain, part of a mountain, and you can have a certain percentage before we start seeing big error rates and other things that affect the quality of the signal.
And there's tons of tools out there. We have our own Mimosa design tool that calculates Fresnel zone.
Yeah.
There's apps for phones, iPhone, Android, online tools other than the design tool that will help you calculate Fresnel zone and line of sight. Again, it's not 100% perfect. It's always best to actually go out and visit the site, climb up the tower and see exactly what you can see on either side, or whatever your vertical asset might be. It's always good to climb up it and see what you can really see from each point.
I use one RF toolbox, and it allows you to enter in the frequency, 5600 meg or 10.368 gig, whatever you're at, and the distance, and it gives you the radius, the overall radius, and then the amount of up to what you want to keep 60% or better of that of the fat part of that zone in there. So it kind of gives you that stuff. You just enter some data in, it gives you a rough idea what you're looking at.
You always aim for 100%, but if you can't get it, 60 is a minimum for nail zone that you need to get a good link. So.
One thing I was going to add too is when you are checking for obstructions with tree coverage, I know this sounds kind of silly, but it's true. Not only do you want to check in the wintertime, but you also want to check in the summertime because the trees having leaves on them. I've seen where customers put up links in the wintertime or even autumn, and everything looks good, and then springtime comes around and all of a sudden their link stops working. So, take in consideration that the foliage is going to change, and this is something you need to check both times of the year.
Yeah, it's a great point. Yeah, we look at that too.
Definitely have experienced this firsthand when I was a newbie at wireless installation. We'd put up links that worked fine in the wintertime, and come springtime when the leaves started blooming, we're like, well, why is the signal dropping?
September, October, November, this is great.
Hey, you'll work during the wintertime, but you won't work during the summertime. So, definitely good rule of thumb is, if you wouldn't install it in the summertime, you don't want to do it in the wintertime either. Right. So you don't want a half a year customer. You want a 365-day-a-year customer.
Yep.
Moving on here, you also want to study your competition. Most WISPs out there, they try to serve the unserved or underserved folks out there in rural areas or maybe even suburban areas that don't have fast providers because they haven't come in and updated their infrastructure. There are some out there who actually do compete with the cable and fiber providers, and they do very well. But again, at the same time, it's because of the quality of service they provide, the quickness of deployment, because it takes a lot longer for a cable line provider to deploy a service to somebody than it does wireless. Wireless you can do in a day, whereas a wireline it takes weeks or months sometimes to get service to somebody. Mm-hmm. Also, a good thing is that you guys are local support. People know who you are. You know your neighbors. You're not just some faceless entity like AT&T, Verizon, Comcast, or any of the big names out there. So people really like being able to know the person that's actually providing them service. And, those guys communicate with each other all the time. Whereas you sit on, a waiting line, for an hour or two trying to get to somebody on the phone. And even then, sometimes you're not going to get somebody on the phone. So leverage that. Leverage the local people that know you. There's tons of people out there who do that and are successful at this.
Yeah, build some rapport. We have a couple of test networks, and these test clients text us on the weekends, or text me, text Dustin on the weekends, and we get back to. We respond back. We have the team ready to go at Mimosa for help, so we know where our references are, and we can reach out and get some help from our whole team, and then we keep in touch with these folks too. So we always have that rapport, and they're happy to really get a response back on time.
They love the extremely fast response time because they have our phone numbers, and then we're out there the next day if there's even a problem. But luckily for us, our Mimosa test networks stay up. It's mainly internal networking issues on their side, or their kid can't get their iPod or iPad connected to the network kind of deal, and it's basic tech help that tech support would do. Also, another good thing is local tech support and not outsourcing your tech to some call center on the other side of the world. People, they want local help. They want to talk to local people, people who speak, like they do. They feel real comfortable with people who talk the same way that they do. And coming from Arkansas, lots of people talk, with a southern accent, and you have the same accent. Everybody gets along with you, but they complain when even somebody from New York gets on the phone. They're like, we can't understand this person. So local help, local support, local installers, people who know other people in the area. That's the only way to go.
Sure.
And then the last thing here is study the spectrum in the area. 5 gigahertz, 900 megahertz, 2.4. A lot of the spectrum is unlicensed, open. Everybody can use it. And so if you're anywhere, suburban, urban, for sure, you're going to run into a ton of interference. And even if you're in rural areas, sometimes you'll run into a lot of interference. So before you decide to deploy in an area, you need to make sure that you look at the spectrum to see exactly how much is usable or how to plan your network. Again, we come back to the planning, because for say if the noise floor is neg 70 in your neighborhood or the area you're trying to deploy, you want to try to keep your subs at like neg 50 or better, because the lower the signal to noise ratio is, the SNR, the worse connection that your customers are going to have and the worse experience you're going to have, and they're going to move back to a wireline provider or somebody who has more spectrum or just a better connection in general. So again, it's always good to go out and survey the area and plan your network. You have to plan it before you try to deploy it, or you're just setting yourself up to fail and waste everybody's time and money. And then you're going to give yourself a bad name, and once you do figure out what you're trying to do, then it's too late by that point.
Yeah, I would actually recommend, if you are to do a spectrum analysis, having a handheld service monitor or a spectrum analyzer device, can be very expensive, up to $10,000 to $15,000. What works really well is using one of our like a B5 Lite or C5 and going into that radio's configuration while you're at the customer site or the potential candidate site, and doing a sampling of what the frequencies look like at that given location. Now, mind you, the frequencies are going to change because this is an unlicensed spectrum. So what you see today may not be the same spectrum tomorrow. So, keep that in consideration. But essentially what you want to do is look for those spikes that you have on that graph and try to mitigate those spikes by looking for open channels. So that's really important to get that information before you actually deploy, more in the planning phase.
Yeah, we'll go out to a site or go to a rooftop, and we'll put a radio on a tripod, and then for power. So if you don't have a 100-foot extension cord or 50-foot extension cord, we'll use a big kind of a car battery, the portable emergency power thing, 12-volt battery on it with a handle and an inverter, and then we'll feed the PoE off of that and connect that to the 5 gig radio and scan the spectrum. So we're completely portable. Maybe a little speaker stand or some kind of little tripod adjustable on the roof, and you're completely mobile at that point as well. So.
And there's been guys recently, building little portable batteries out of like DeWalt batteries or, things like that, where they can carry it around.
It's safe.
It's real light.
Yeah,
but they can plug a PoE into it. It'll power their radio for however long they need to, just to do a site survey or to, look at the area and see what's going on. But, people are innovating and making, smaller devices and gadgets every day to make life easier on people. So, and I think that actually, like DeWalt and Makita are actually selling things like this now because people are modifying their stuff to do this.
Yeah, you got to play that business safely. Yeah.
All right, so now we're going to move on to tech tips, and today our friend Jeff here is going to give us a tip on what to do or what not to do.
Well, since today is the second day of spring, I think it'd probably be appropriate to talk about weatherproofing. Our tech tip today is obviously around weatherproofing the end connector on the B5C radio. Well, we have seen a fair amount of support cases come in where radios will exhibit strange behaviors. One that comes to mind is chains 1 and 3 or 2 and 4 being out of balance with the other chains. And what happens is the actual RF coax gets an ingress of water in it and causes this to change the dynamics of the cabling. So one of the quick and easy ways to resolve that, well, obviously you have to replace it if that's the case, but one way to have that situation not happen is to do a really good job at weatherproofing. And I'm sure Eric can talk a little bit more as far as how that looks, but we see a fair amount of issues around waterproofing. So, again, this being the second day of spring and we're not out of the woods when it comes to rainy weather, don't cut any corners when it comes to weatherproofing your product there, because we really want to make sure that it doesn't fail in a storm. It's not a good time to go out and replace radios anyway. So,
well, I definitely have a first-hand experience on badly wrapped LMR cables and water getting in the connectors after storms. So I definitely want to make sure that you seal it up. We've got our special vulcanized tape that comes in our kits, or there's mastic tape you can get at satellite stores, or at Home Depot if you really have to. A lot of people do electrical tape first and then mastic, or mastic then electrical tape, then mastic again. There's a lot of different ways out there, but you just need to make sure it's tight and it's sealed, and there's no way that moisture can get into that connector.
If you're bringing a drip loop from your LMR 400, or you're bringing it in, and it's coming back into the radio, and there's you get rain, and rain's going to fall. And if rain collects underneath one of your products, it's very important the way you wrap your mastic or your self-vulcanizing tape or your coax seal. If you do it the wrong way, if you roll it, you wrap it up. If you do it the incorrect way, water collects and can seep and ingress into that tape joint at that point. So you got to make it so you got to think so that no matter it's being hit with sideways snow, rain, whatever's coming down on that seal point, that it falls with gravity, rolls off. So instead of some of that stuff will be captured and goes in. So we don't want to do that. We want to keep it the right way.
So if you've got like a B5C, you want to wrap from the bottom up toward the bottom of the radio. That way the overlap is where water won't catch on it. It'll just roll down.
Yeah.
If you wrap it the opposite direction, then you've got overlaps every section and more chance of moisture to get into the connector. So you just have to look at the direction of it. We actually have some pictures on our help site on how to do this, and I'm sure there's tons of YouTube videos out there that detail this even more in depth than what we have to help you wrap your connector, so you don't have to worry about going out and replacing those every storm.
And drip loops and et cetera. Yeah.
All right, so wrapping up here, we talked about evaluating an area. So we talked about towers and rooftops, relay sites, and we talked about topography. Then in neighborhoods, we talked about density, tree coverage, spectrum, and competition. So the takeaways from this is you need to plan your network. You need to go out and actually visit the sites before you do anything. You also need to find a source of money, because you can't do a whole lot without that. So you have to have a business plan prepped and ready to go before you start looking for anybody that is willing to let you have or borrow money to build your network. So you have to spend a lot of time thinking about what you want to do before you actually try to go out and start putting something together. So next week we're going to be talking about finding a backbone provider. So we'll see you next time on our next Dustin and Eric podcast show. Thanks, Jeff, for coming in. I appreciate it.
Thanks, Jeff.
Pleasure.
Thanks for tuning in. Please hit the subscribe or follow button to stay up to date with our latest podcast, which will be available on YouTube, iTunes, Google Play, and SoundCloud.